Okay, we have an object. I'm in no way claiming this to be any specific type of object because I just made up the equation. So we have an object whose position is described by this equation. 4 meters, e exponential function to the negative 6t. By the way, what units does the 6 have to have?
Meters per square.
Just seconds.
What units does the power up here have to have? Can you take e to the something with units? No, you can't. You can take e to the number, but that number cannot have units on it. So we need to have no units up here. So what units does the 6 have to have, such that when we multiply it by time, we end up with no units at all? 1 over seconds, exactly. So the 6 is 6 per second. What I would like to know what will the acceleration be when the velocity is negative 2 meters per second? So this means we need an equation for acceleration and we need an equation for velocity both to work with. Because number one, we're going to have to use the velocity equation to figure out what time this happens at. And then once we have that time, we're going to come back and figure out what the acceleration value is. So, velocity. If that's our position, what will our velocity be?
Negative 24 e to the negative 16.
So, derivative of the exponential function is the exponential function times the derivative of the power. So negative 6 times 4, the eternal function, yeah. Gotcha. So 24 meters per second we get in front, and we still have e to the negative 16. Meters per second, the seconds came from that 6. Remember we said the 6 had units of 1 over seconds. That's how we ended up with meters per second. We need to take the derivative again.
144 e to the negative 6.
Oh, leave my units on there. There we go. So we have our equations that are describing the position, which was given, the equation now that describes the velocity of our object, and the equation that describes the acceleration of our object. So the equations, not too hard to come up with. We have the calculus relationships, that works nicely. Now, you gotta do some calculations. Our end goal is to find the value of the acceleration. But we can't find the value of the acceleration without knowing the time. So we need to know what time we want to find the value of the acceleration. Well, we want to find the value of the acceleration when the velocity is negative 2 meters per second. There's going to be a point in time when the velocity is negative 2. So what we need to do is take our velocity equation. Where am I going to put the negative 2? Right there? We're going to put it in for the velocity value. Exactly right. So negative 2 goes in for the velocity value. So like we did on the math review here, we need to divide by the 24 first, the negative 24, so we can get the exponential by itself. We're going to take the natural log of both sides, so the natural log of 1/12 will equal the natural log of the exponential function. Those cancel. That leaves us with negative 6t. So t will be negative natural log of 1/12 over 6. Remember the 6 had units of 1 over seconds? So this is going to give us units of seconds. .414. Now as a general rule, as you're solving problems, keep a few decimal places until you get to a final answer. You end up causing yourself problems if you start rounding really early on. So keep a few decimal places until you get to the end. Then you can round to your appropriate decimal place. Usually with our homework system, unless told otherwise, they generally want 3 significant figures. That's just a general rule. Sometimes they'll tell you a different number, but if you're not told a different number, then just use 3. So now we know what time the velocity was negative 2 meters per second at 0.414 seconds. So now we have a time. We can take this time and put it in over here. So our acceleration at that time is going to be 144 meters per second squared times e to the negative 6 times 0.414. Uh-huh.
You said that going back up to the 6 had a 6 per second.
Yes.
Where does that leave in t?
So 6 per second brought the seconds up top
Okay.
and left us with seconds for our units on time. That's a nice round number. So 12 meters per second squared is the value of the acceleration when the velocity is negative 2 meters per second. It's positive. Means it's headed in the positive direction. Whether that be that way or that way, we didn't specify exactly what direction our object was moving in. So it's the positive direction, whichever way that happens to be.
So the 1 over s doesn't affect that at all?
Well, the 1 over s canceled out with the s on the seconds. So the units cancel, leaving us with just the numbers to multiply together. Okay? Other questions?